Well, hello there. It's me again. Hey, we know some things about simple machines. We know that machines do one job, exactly one job. What do? All a simple machine can do is make work easier. Right on? Hope that's getting pretty comfortable. Make work easier. That's what a simple machine does. Now, we looked at a pulley system right off the bat, and yesterday you looked at some mechanical advantage problems, because now that's the answer to the second question. If simple machines make work easier, the question is, how much easier do they make work? And as we've been seeing, how much easier a machine makes work is called mechanical advantage. One of the things that you've now been able to use is an equation to calculate mechanical advantage. And the first way you did that was using this tool right here. The mechanical advantage is output force divided by input force. That works great in most situations. Now, what I want to do today is show you two new tools that you can use to think about simple machines. One of them is real specific to levers. Now, I think you know that a lever is a simple machine. A lever is just a bar that pivots on something. And if we look at this picture as an example of a simple machine, you got a person over here pushing down on a lever. And what you notice about that person is they're pushing down. First of all, I'm too big, so I got to shrink. There we go. You notice this person over here is pushing down on a lever with a force. Same idea we had before, input force. And what the lever is doing is putting out an output force. And you'll probably notice the input force is smaller and the output force is bigger. But one of the things we can also measure about that type of machine, a lever, is called the arm length. That is how long the arm is from the place where it pivots, that's called the fulcrum, up to the place where the force is applied. So if we think about the fulcrum, for this lever, it's a log. The distance, let me do that again. The distance along the lever up to the fulcrum is called the input distance. So if I draw a line right along the lever, and you think about how long that arm is, that's called the input distance, or the input arm. LI, lever input, is what they do up there, input arm length. Now the output arm is the same idea, but of course it's the arm on the other side. So if we go to the other side of the lever and we start at the pivot point, and we go over this far, this arm is called the output. So they call it the output arm length, or length output. And you'll notice the mechanical advantage of a lever is also that ratio, input over output, if we use the lengths. Now be really careful, because you notice for levers, this is length to get mechanical advantage. However, the equation we used before was force. And for length, input is on the top and output is on the bottom. But for force, you notice output is on the top and input is on the bottom. Easy to keep track of, but just be careful that doesn't get you confused. So again, for levers, that's a nice new tool that simple machines make work easier. We can either use force out over force in, or now we can use length input over length output. That also works for levers. One more thing to think about, and that is, what about a ramp? Here you see information about a ramp where we use length and height. Again, let's go down and look at a picture. Here's a picture of a ramp, another kind of simple machine. And again, instead of having to lift the object straight up in the air, you can pull it or push it along the ramp. And in this case, to find mechanical advantage, as you see, we can measure how long it is up the ramp. In this case, 10 meters. And that would be called the ramp length, or again, the input distance. And you see that right over here, ramp length. You could also call it input distance, that's what it is. And again, on the other side of the ramp, the job that gets accomplished is the thing actually gets lifted just this far. In this case, it just gets lifted a meter. So the ramp height would be a meter. So you'll notice on this sample problem that, again, the ramp height goes on the bottom, 1 meter, and on the top goes the ramp length. That would be, in this case, 10 meters. And just like before, notice the units cancel out. 10 divided by 1 is 10. The mechanical advantage of this ramp is 10. And again, the units cancel top and bottom. So let's recap that real quick. So we talked about mechanical advantage in general as force out over force in, and that's the idea we started with yesterday. That works for machines. But specifically for levers, we know that it's the input arm divided by the output arm. And again, the input arm is the length on the inside and the output on the outside. And then for ramps specifically, it's the same as the length of the ramp, which is the input distance, divided by the height of the ramp, which is the output distance. So really just a couple more tools, a ramp tool and a lever tool to use for simple machines. And today, again, your job is to figure out some quick mechanical advantage problems. The first set are for levers, and the second set are for ramps. So again, try using those two tools, ramps and levers. Just to recap one more time, let's write down those equations. I would strongly encourage you to stick those in your physics journal. So MA for a lever, we're talking length in over length out. Yeah, that's an I over length out. And if we're talking about ramps, MA for a ramp, we're talking about the length of the ramp, which you could also call the input distance, that'd be okay, but the length of the ramp divided by the height of the ramp, which again is the output distance. So length over height. Again, if you want to write down those two tools for your notes, that would be super handy as we proceed through this unit. So today, again, please try those two sets of problems. They're just a continuation of what you were working on yesterday, and then turn in the whole shebang when you're done. Please do notice there is a key posted, and I'd encourage you to check those answers as you go. Please grab questions with email or stop into office hours, and I'll be happy to give you a hand. Have a great day.